Of all the tools that a line crew uses, rope has to be the most universal and versatile. Rope is used to lift a variety of loads, to secure tools and equipment to poles, as a safety line in the event of an emergency, and as a safe and efficient means of supplying a lineman with the materials and tools necessary to do a job. There are literally thousands of different types of rope. Rope comes stranded, braided, plaited, and in other designs too numerous to mention. Now, each of these types of rope can be used for rigging jobs. The most common type of rope you'll be working with, however, is stranded rope. A stranded rope is made up of individual fibers that are twisted together to form strands. In this example, there are 3 strands. Then the individual strands are twisted together to form the fiber rope. Now, the sizes of the rope typically used in overhead line work range from 1/4 inch to 1 inch in diameter. The material the rope is made of, the weight of the load, and the company procedure dictates what size rope is necessary to do a job. A rope is generally classified by the type of fiber that is used to manufacture it. In general, there are 2 broad classifications: natural fiber rope and synthetic fiber rope. Now, among the natural fibers are manila, sisal, and cotton. Manila is often used as a standard for comparing rope strength. Now, among the synthetic fibers, there are nylon, polydacron, and polypropylene. Now, natural or synthetic fiber ropes can be used for line work. The 2 most common types that you'll be working with are manila and polypropylene. What you use will depend on your company. Now, as part of your upfront planning of a job, you need to decide what size rope is needed to handle a load. Experience plays a large part in this decision. However, rope manufacturers test the capacity of their ropes and publish load information and comparison tables. These tables are available from the manufacturer and are also usually published in safety manuals and rigging handbooks. Here's an example of what comparison tables look like. This table compares the safe working loads of various sizes of manila, polypropylene, and polydacron rope. Working load is the industry term that indicates the maximum load that a rope can withstand without significantly damaging the rope or its fibers. Now, according to these tables, a 1/4 inch manila rope can safely lift 100 pounds. The same size polypropylene rope can lift 220 pounds. And a 1/4 inch polydacron rope can safely hold 380 pounds. Now, while comparison tables are an easy reference to help you plan your job, there are a couple of things you need to understand about these tables. First, the comparisons are general guidelines and refer to new rope in good condition. If you're using used rope, you have to reduce the limits of the tables. Your company will probably have recommendations as to how much of a reduction in safe working load is required. Second, you need to understand that the figures in the tables refer to rope that is free of knots and splices. Again, the safe working load has to be reduced if the rope has been spliced or joined to other rope using knots. Now, finally, tables may indicate breaking rather than the safe working load of a rope. Breaking strength is the tension at which new rope will tear or break. This is generally 5 to 10 times greater than the safe working load. Now, it's important that you recognize the difference in these terms and follow your company's procedures for determining the safe working load of the rope you're using. Now, the rope that's used for rigging purposes has a number of characteristics that you should be aware of. Now, these include load strength, flexibility, resistance to abrasion, chemicals, solvents, moisture, and mildew, its elasticity, and its dielectric strength. Now, if we compare manila and polypropylene rope to each other, we find that both have a high load strength, with polypropylene being the stronger of the two. Both types of rope are flexible and easy to work with. Manila is a bit more flexible and tends to hold knots slightly better than polypropylene. Both ropes are also resistant to abrasion, chemicals, solvents, mildew, and moisture. Manila, being a natural fiber, tends to be affected by moisture and subject to rot and mildew to a greater degree than polypropylene. However, polypropylene, being synthetic, is more subject to damage from chemicals and solvents than manila. Linseed oil, for example, can ruin polypropylene rope. Now, in terms of elasticity, which is the tendency of all rope to stretch under load, polypropylene can handle greater loads, but stretches more than manila. Now, finally, when new, both ropes have a high dielectric strength. This means that neither conducts electricity well. This is very important to a line crew, since there's always the possibility that a rope may contact an energized conductor. Now, your textbook has a chart that indicates these and other characteristics of various types of rope. Like any tool, it's important that you periodically inspect rope for damage. Your company will probably have procedures that indicate how often a rope needs to be inspected, but it's a good idea to inspect rope whenever it's used. A damaged or overloaded rope is an unsafe tool that can put your safety and your crew's safety in jeopardy, as well as cause damage to expensive equipment and materials. Damaged rope should not be used for rigging. Now, when inspecting a rope, you need to look for frays and breaks in the fibers and strands. It's natural for new ropes to fray a bit when used. This initial fraying actually protects the rope from further damage due to abrasion. However, excessive fraying or tears in the fibers or strands can reduce the life and load capacity of the rope. Here, for example, you can see broken fibers on the outside of the strands. This rope needs to be replaced. Now, you also need to open up the strands of the rope and see what the rope looks like inside. It's often these interior fibers that indicate the worst damage. The inside fibers should be bright, clean, and free of dirt or oil. However, if you find that the inside fibers are extremely dirty, oily, or that they're coated with a powdery substance, this tells you that the rope has been subjected to excessive strain and chafing. Now, here you can even find broken fibers. This rope should also be replaced. In addition to checking for broken fibers and strands on the inside and outside of the rope, you need to look for unnatural bends along the entire length. All rope bends and kinks to some degree, but something like this, often referred to as a hockle, shows that this part of the rope has been crushed or bent around a piece of equipment. Unnatural bends significantly weaken a rope, making replacement necessary. Now, finally, you need to be alert to indications that the rope has been exposed to excessive friction or high temperatures. This is particularly important when using synthetic ropes that usually have low melting points. This rope was exposed to excessive heat and has melted. It's not good for a rigging job. Excessive friction, chafing, and contact with hot surfaces can cause this kind of damage. Now, so far, we've shown you how stranded rope is made, the characteristics of a rope used for rigging, how to find the safe working load of a rope, and how to inspect it. The last thing we'll cover is rope terminology. There are fairly standard terms used to describe the various parts of a rope. These terms will be used in the next part of the program when we discuss knots. The terms include the standing part, or end, the running part, or end, a bight, and a loop. Now, the standing part of a rope is its principal or longest portion. This part consisting of the greatest number of coils, would be considered the standing part. This end, which we would tie to another rope or to a piece of equipment, is generally referred to as the running end. Now, the running end may have an I-splice in it, like that, or it may be left plain with its end secured to prevent fraying. Now, sometimes the running end may be referred to as the fall line or load line, depending on how the rope is being used. A bight is any bend in the rope that puts the standing part and the running part parallel to each other, like so. It's often necessary to tie knots using a bight, especially when you have a long length of rope and it's inconvenient or impossible to use the end. Now, finally, there is the loop. A loop is any turn or bend in a rope that causes the standing part and the running part to overlap each other, like so. Loops are the basis for a number of knots that you'll use often and need to master. Now, we'll be looking at knots and knot tying in the next part of this program. Right now, review the material on rope that's in your text and answer